Next question is given investment is equal to 50 plus 0.2y, savings is equal to minus 150 plus 0.4y, government expenditure is 50, find equilibrium level of income. Okay, so how do we find the equilibrium level of income? We have our y should be equal to consumption expenditure plus investment expenditure plus government expenditure. Okay, so since no consumption expenditure is being given here, we can calculate the consumption function. So how can we find the consumption function? We know our income can either be consumed or saved. Okay, so if we solve this very function for c, that means c is equal to y minus s. Okay, so c will be equal to, let me write it here, c is equal to y minus, what is our s? S is this very function, so let me write it here, y minus 150 plus 0.4 y. Okay, so because we need this c to calculate the equilibrium level of income, that means this comes out to be y minus minus is plus 150 minus 0.4 y. Okay, which implies c is equal to, when we subtract 0.4 from y, we will get 0. So let us write first this 150. Okay, now subtracting 0.4 to y, we will get minus 0 point, sorry, plus 0.6 y. Okay, this is our consumption function which we use in calculating our equilibrium level of income. So our y is equal to, our consumption function is 150 plus 0.6 y. Our investment function is being given us as 50 plus 0.2y, 0.2y plus government expenditure, which is being given us here 50. Okay, so well, let us solve this. We have 0.6y, 0.2y, this becomes 0.8y. We have 150 plus 50 and plus 50, so this is 50 gai hath gai doi hath, that is 250 obviously. Okay, so y transposing this 0.8y to LHS, we get 250 here, which comes out to be 0.2. Okay, when subtracting 0.8y from y, we get 0.2y is equal to 250, which implies 2 upon 10. Y is equal to 250, which implies y is equal to 250 into 10 upon 2. Okay, so 2 ones are 2 5s are 10, that means y is equal to 5 zeros are 0, 5 5s are 25, 5 2s are 10, 11 12. Equilibrium level of income will be 1250, so the correct option should be a option. Okay, next question is, which of the following functions will result in an investment multiplier of value 4? Okay, so we have to see which of these will give us the value of investment multiplier is 4. The options are c is equal to 50 plus 0.25y, c is equal to 50 plus 0.75y, s is equal to minus 50 plus 0.25y, I is equal to 50 plus 0.75y. So we should get the investment multiplier of value 4. Okay, let's take this first one. Okay, consumption is a function of income here. Okay, and this 0.25 is our marginal propensity to consume. Okay, how much we consume when our income changes by 1 unit. Okay, so our MPC, sorry, is equal to 0.25. We know investment multiplier is being given by del y upon del I is equal to 1 divided by 1 minus MPC. Okay, so we should get a value 4. Okay, if not, then this option will not be correct. So we have 1 upon 1 minus MPC is 0.25, 0.25. This comes out to be 1 upon 0.75, which is equal to 1.33. Okay, so we did not get the value as 4, so this option cannot be correct. Okay, coming to the next option, consumption is equal to 50 plus 0.75y. Again, this 0.75y is our MPC. So in this case, our MPC is equal to 0.75. Okay, so investment multiplier is given by this very function, which implies our del y upon del I is equal to 1 divided by 1 minus MPC is 0.75, 0.75, which comes out to be 1 upon 0.75 is 0.25. Okay, 1 upon 0.25 comes out to be exactly 4. Okay, so this option is correct. Okay, coming to the next option, so here we have savings is a function of income. Okay, s is equal to minus 50 plus 0.25y. This 0.25y denotes the marginal propensity to save here. Okay, so our marginal propensity to save is equal to 0.25. Okay, so what is the relationship between MPS and MPC? MPS plus MPC, as you know, is equal to 1 if MPC will be equal to 1 minus MPS. That means we can calculate the MPC from MPS by, that means our MPC is equal to 1 minus MPS. MPS is 0.25. Okay, and this comes out to be 0.75. Again we got MPS is, sorry, MPC is equal to 0.75. Okay, so if we plug again this in our investment multiplier function, we will again get 1 upon 0.2. Okay, so this option is also correct. Okay, now third option is I is equal to 50 plus 0.75y. That means investment is a function of income, and this denotes our marginal propensity to invest. Okay, so the formula is this. We have no MPI here. That means this cannot result the value of our investment multiplier equal to 4. Okay, so options will be B and C will be correct. That means this option is correct. Next question is, given y is equal to x cube minus 12x square plus 36x plus 8. Identify which of the following is correct. Y is maximum at x is equal to 6 and minimum at x is equal to 2. Y is minimum at x is equal to 6 and maximum at x is equal to 2. Y has two inflection points at x is equal to 2 and x is equal to 6. Point of optimality is indeterminate. Okay, so first we will see how to find maximum and minimum pointers here. Okay, so this is our function. Okay, to find maximum or minimum pointers, what we need to do, we just need to take the derivative of this very function first. Okay, with respect to x and set it equal to 0. Okay, so for optimum, okay, for optimum we differentiate this with respect to x. Okay, so we take dy upon dx is equal to 0. Okay, so if we take derivative, this becomes 3x square minus 2 into 24 is, sorry, 2 into 12 is 24x plus the derivative of x is 1, so we are left with 36. Derivative of constant is 0, so we equate this equal to 0. Okay, to find the critical points where it is at maximum or minimum, so we can find the critical points here. Okay, if we set this equal to 0 and solve, so if we take 3 as common, so let's take 3 common, we are left with x square minus 8x plus 12 is equal to 0. Transposing this 3 here, it will get divided to 0 and it will become 0. That means x square minus 8x plus 12 is equal to 0. Okay, so this is a quadratic function. We will get two optimum points. Okay, so let us solve this very quadratic function. We can factor this out also. That is x square minus, we can write it here, 6x minus 4x. I hope you know, I have explained it in several videos, how do we separate the middle term if it exists. Plus 12 is equal to 0. Okay, so taking x here common, we have x minus 6. Here taking, sorry, we have here minus 2. Okay, and taking minus 2 common, we are left with x minus 6 and set it equal to 0. That means x minus 6 is equal to 0, or x minus 2 is equal to 0. That means x is equal to 6 or x is equal to 2. We got two optimum points. Okay, now we need to find out where these 2 points lie, whether this point is at minimum or maximum, or whether this point is at minimum or maximum. For that, what we need to do, we just need to take the second derivative of this function. Okay, so this is our first derivative. Now taking second derivative means d square y upon d x square. Okay, so if we take the second derivative of this function, so we will get 3 2s are 6x minus 24. Okay, to find which of these 2 points is at maximum or minimum, for that we need to take the second derivative and put these pointers here. Okay, put the values here and see. So let us put first x is equal to 6. That means d square y upon d x square, and evaluating first at x is equal to 6. So we have 6 into 6 minus 24, which comes out to be 36 minus 24. This is equal to 12. Okay, which is greater than 0. We got the second derivative greater than 0. So let us graph this out so that you get the complete area what I mean to see. Okay, so actually we have this very functional this cubic function. We have 2 pointers. Okay, for maximum, okay, let me write it here. For maximum, first our let me write it here. For maximum, first derivative, that means dy upon dx should be equal to 0, as we have done here. We set it equal to 0, and d square y upon dx square, that means second derivative should be less than 0. Okay, when we put the critical point into the second derivative, it should be less than 0, but here we got a number which is greater than 0. So this is for maxima, and for minima we have same thing. Dy upon dx should be equal to 0, and second d square y upon dx square, it should be greater than 0. This is the condition for minimum. Okay, sorry, minima. So here we can see, first when we set dy upon dx is equal to 0, we got 2 pointers. To check whether this point is at minimum or maximum, we need to take second derivative. We took the second derivative and evaluated at this critical point. We got a number which is greater than 0. Okay, that means this very number, this very point is at minimum. Okay, so here the slope is equal to 0, and second derivative is rising. Okay, so slope of the slope is positive. That means this point x is equal to 6 is at minimum. So we have here x is equal to 6. Let me write it here. So this will be minimum point, and this 2, let us see when we put this again. If we put 2 in place of 6, so let us see what happens to the second derivative. So we have 6 2s are 12, 12 minus 24, which comes out to be minus 12, which is less than 0. Okay, so when we evaluated x is equal to 2, okay, in our second derivative we got a number which is less than 0, and this very point satisfies the condition for maximum. So okay, when this is 2, so we have a maximum point, and when x is equal to 6, we have a minimum point. Okay, so y is maximum when x is equal to 6, and minimum at x is equal to 2. Is it the case? For maximum, what we got here, actually we got this very 6 at minimum. So y is minimum when x is equal to 6, and maximum when x is equal to 2. Okay, and this option cannot be correct. Second option is obviously correct. Okay, so the third option is y has 2 inflection points. Okay, by inflection we mean a point where the function changes its concavity. Okay, so let us say this is a point. Okay, up to this it is concave up, and up to this it is concave down. Okay, to find the inflection point, what we need to do, we just need to set our second derivative equal to 0. Okay, this is our second derivative. If we set it equal to 0, we will get the inflection point. So 6x minus 24, 6x minus 24 is equal to 0, which implies 6x is equal to 24, which implies x is equal to 24 upon 6, 4. Okay, so inflection point will occur at x is equal to 4. It is saying there are two inflection points, x is equal to 2 or and x is equal to 6. That cannot be the case here. Okay, I hope I make myself clear in this video. So for maximum, first we need slope should be equal to 0, and the slope of the slope, what we call the second derivative, should be falling. Okay, which we have seen here. And for minimum, obviously slope should be equal to 0, and the slope of the slope, what we call the second derivative, when evaluated at critical point, should be rising. That means it should be positive, or we can say this d square y upon d x square should be less than 0 here, and here d square y upon d x square should be greater than 0. Okay, these are the conditions for maximum or minimum. Next question is, assuming the probability of a male birth is 0.5, find the chance that a family of 3 children will have 2 boys and 1 girl. Options are 1 upon 8, 2 upon 8, 3 upon 8, 4 upon 8. Okay, so we need to find the probability that in a family there will be 2 boys and 1 girl, when in a family there are 3 children. Okay, so what is our sample space here? Okay, so 3 children can be like this. We can have 3 boys. Okay, we can also have 2 boys and a girl. Similarly, we can have first is boy, then we have girl, last is also boy. Okay, and we have boy, girl, 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 boy, and girl, boy, boy, and girl, boy, and girl. Okay, these are the combinations that will have when we have 3 children. Okay, so how do we interpret that? That means first child is boy, second is also boy, third is also boy, and similarly here first child is girl, second is boy, third is boy. Okay, now what we need to find, we need to find the probability of getting 2 boys and 1 girl, 1 girl. Okay, so if this is our sample space, what are our favorable cases? So in a simple sample space, we need to see 2 boys and a girl here. Okay, so this option is our favorable case. Here also we have 2 boys and 1 girl, and here we don't have. And in the penultimate case, we have 2 boys and 1 girl. That means we have how do we write the chances? We probability here, so we write it favorable cases, favorable cases upon sample space. Okay, total number of cases, sample space. Okay, so number of favorable outcomes are 1, 2 and 3, so we can write here 3. And number of combinations we have here 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the correct option should be 3 upon 8, this option. Next question is, the concept of money illusion was first given by Irving Fisher, James Keynes, Milton Friedman, or Robertson. Originally, this money illusion concept was given by Irving Fisher. Okay, the correct option should be this Irving Fisher. Okay. Next question is, as output expands, long run average cost falls. This is due to options are diseconomies of scale, economies of scale, law of diminishing marginal returns, and there was other option I was not able to encounter here. So how do we interpret the long run average cost? We have this long run AC. Okay, this portion shows us the what we call economies of scale. Okay, so the following portion of long run average cost is given by economies of scale. Okay, by economies of scale we mean when more units of a good can be produced on a larger scale with fewer input costs. That is what we call by economies of scale. Okay, so next question is Human Development Index HDI, currently as published by the UNDP, is calculated by which of the following method? Arithmetic mean, geometric mean, harmonic mean, or quadratic mean. In calculating HDI, we use the geometric mean. That means we take the geometric mean of the three proxy variables, that is standard of living, per capita income, and life expectancy. We take the geometric mean of the three proxy variables. The correct option should be geometric mean then. Okay, next question is what type of relationship the Phillips curve postulates between rate of unemployment and rate of increase of money wages. Okay, so the relationship between the unemployment rate and inflation given by the AW Phillips is the inverse one. Okay, there is inverse relationship between if we calculate unemployment here and inflation here, there is the negative relationship, what we call the inverse relationship. The correct option should be inverse. Okay, next question is match the following tables. So convex function, to check whether a function is convex or a concave one, for that we take the use of derivatives. So convex function should be use of derivatives. Input output analysis, in this case we use Hawking-Simon's condition to check the viability of the model. In linear programming we have the basic variables, and marginal propensity to consume will be to demand curve here. Okay, next question is total number of population of city X in 2011 was 28 lakh and total number of live births was 50,000. Find out crude birth rate per thousand population. Okay, how do we calculate crude birth rate? It is being calculated by, let us write, CBR is equal to live births upon total population, okay, into 1000. Okay, this is the formula for this. So what is the live births? This is 50,000, so we can write 50,000 upon total population is 28 lakh, 10 lakh into to this we multiply 1000. Okay, so these three zeros will get cancelled with these three zeros. Here we have these two zeros will get cancelled with these zeros, so we are left with 500 upon 28, which will give us 17.85 as the correct option. So this option should be correct one. Next question is, at present the estimation of GDP in India at constant prices, which one of the following years is used as base year? The options are 2002, 2001, 2010 11, 2011 12, 2014 15. The correct option should be 2011 12. This is the base year which is being used in calculating the GDP at constant prices. Okay. Next question is when the exchange rate changes from $1 is equal to 72 rupees to $1 equal to 68 rupees, then the options are rupee has depreciated, dollar has depreciated, rupee has appreciated, dollar has appreciated. Okay, so let us see what does this mean. This thing, $1 is equal to 72 rupees, means that we need 72 rupees to purchase $1, and then we are being told $1 is equal to 68. Now only we need only 68 rupees to purchase $1. So this means rupee has appreciated. Okay, that means rupee has appreciated, it became strong, and at the same time dollar has depreciated. Okay, so if one currency appreciated, that means another currency should depreciate. They cannot both appreciate at same time. Okay, so the correct option should be rupee has appreciated and dollar has depreciated. Okay, so the correct options should be B and C options. Okay, next question is, in a situation of decision under uncertainty, if a consumer faces equal expected income from two alternatives, then he or she will take decisions on the basis of the options are expected utility of both the alternatives, mean of risk of each alternative, probability of risk attached with each alternative, variation of risk attached with each alternative. The correct option to this question should be expected utility of both alternatives. Okay, when we have same expected value from two lotteries, okay, then to differentiate or to see which, rather what we can say, to take a decision which one to play or not to play, we actually compare their expected utilities. Okay, next question is match list 1 with list second. We have Carl Federgas here. This is related with OLS, ordinary least square. Multicollinearity means the relationship among explanatory variables. Mode is a measure of central tendency, and correlation coefficient is related to Carl Pearson. Okay.